cloud. Finally, we get to use factoring and apply it. I need a pen. And so in section 5.5, what we're going to do for the first time is we're going to use factoring to solve an equation, a very common style of equation. So what we're going to do is we're going to solve what's called, and I will define this term for you. It's a fun math word to say. We're going to solve what's called a quadratic equation. Okay, we're going to solve quadratic equations in this section. We're going to do it by factoring. Now, in case you don't know what a quadratic equation is, if this is the first time hearing the term, I'm assuming if you took any algebra at all in high school, you've done this and done it a whole lot. But if not, that's fine. I don't make any assumptions here. The quadratic equation is something that has a highest power of 2. It's called a second degree equation, a degree 2 equation. When you get to pre-calculus, you'll learn how to solve degree 3, degree 4, degree 5 equations. It's lots of fun, but this is the extent, this is the highest degree equation we're going to solve in this class. And in fact, we're going to solve it by factoring here. The very last section in this class, we're going to learn how to solve any quadratic equation, whether it factors or not. So the good times are going to keep going. Okay, so we're going to solve quadratic equation, highest power of 2. So what I'm going to show you is what's called the standard form, so that you can identify a quadratic equation when you have it. All quadratic equations that you're going to solve are going to look like this. Okay, so the first term, I'm going to put my terms in descending order. That is very helpful and in fact necessary when we go to factor it. So my first term is going to be any number. A stands for any number times x squared. There's my degree 2. My highest power is 2. Plus any number, well, I've already used A, so I'm going to use B. These are the common letters used throughout math and math textbooks and everywhere. So B times X, that's my middle term, plus any number, a constant added on, and it's equal to 0. This is called the standard form of a quadratic equation. And so whenever you solve, however you solve it, we're going to solve by factoring in this section. You always want your quadratic equation to look like this. You want it to be equal to 0. Okay, the reason for that is this. This is the only new bit of information in this class, or excuse me, in this section. And then we're going to apply our factoring. So I am going to ask you a little trivia problem here. So if the following is true, I'm going to give you a little bit of information, and then you are going to help me come to a conclusion. If I tell you the following, okay, so we're at a party, we're talking to each other, and if I say, okay, you've got 2 numbers, you're multiplying them together and they equal 0. I'm not telling you what the numbers are, but I'm telling you that I know this. If I have 2 unknown numbers and I've just multiplied them together and I get 0, then what can you say about the numbers? Yeah, 1 has to be 0 because in multiplying, if I'm multiplying 2 things, the only way to get 0 when you multiply is to multiply by 0. So if A times B is 0, then either A equals 0 or B equals 0. So a little logic puzzle there. Now our book calls this the principle of 0 products. I call it the principle of common sense. It's just arithmetic. Okay? If you have 2 things multiplied to get 0, then one of the 2 things has to be 0. And so how we use this is in the following way. So here is our first example. If I have this, x plus 8 times 3x minus 4. I've already factored something. It's already written as the product of 2 things, and it's equal to 0. Just giving everybody a chance to get caught up writing. Just get excited, and I write fast. So what I have here is I have a first number I don't know. It's x plus 8. I don't know what it is. Times a second number I don't know. But what I do know is that when I multiply these 2 things together, whatever they are, I get 0. Well, that's good news. That means I can apply what I just have up here. So what we'll do here, this is kind of the middle step of solving a quadratic equation. what I'll do here is I'm now going to say, okay, well, if this is true, then either x plus 8 is equal 0, or the 3x minus 4 equals 0. One of those two things has to be true, because we know this times this equals 0. So now what I'm going to do is I'm going to subtract 8 from both sides of this. We've been solving things like this since the first day we met each other, and I get negative 8. Now let me pause here before I finish up the problem. Let's see what this means. So I take my negative 8. When I put negative 8 right here, what's negative 8 plus 8? I'm going to put negative 8 in here. 3 times negative 8 is negative 24. Negative 24 minus 4 is negative 28. It doesn't matter what it is, but I'm just showing you that this is true. What's 0 times negative 28? Perfect. We found one of the solutions to this equation. Same thing here, although this one's going to turn out to be a fraction. I'm going to add 4 to both sides. 0 plus 4 is 4. Divide by 3. And I get 4/3. There's my other solution. And you're welcome to plug that in. 4/3 makes this 0, makes this 9 1/3. 0 times anything is 0. So my solution, one other little thing, we're solving an equation. So we're going to write our answer as a set, showing you good notation. I want you to leave here knowing how to write things well. So we're going to put a negative 8 and we're going to put a 4/3 in our braces. These are braces. They indicate a list. There's 2 answers. Do not put parentheses here. This is not an interval. Do not put squared off brackets. It's not an interval. Those will be wrong. Okay, there's only 2 answers. And it's this list right here. Question in my class yesterday, hey, Kirkster, can I put these in a different order? Yes, I don't care about the order. Okay, it's not wrong at all. So if you got the 4/3 first, comma, the negative 8, it's not interval notation, so you can put them in a different order. So here's one for you. I just want you to step through the principle of zero products for a problem. If you have a question about that, please don't be shy, ask it. You guys don't tend to be shy anyway, but just in case. So here's yours. X minus 5 times 4x plus 7 equals 0. All right, so I'm going to take each of my 2 factors because, again, I have 2 things that I don't know being multiplied together. But I do know when I multiply them, I get 0. Has to be 0 here. We'll talk about that a little later. So since they're equal to 0, I can now take each factor and consider them separately. So the first answer to this problem is if x is 5. That meets this requirement because 5 minus 5 is 0. And 0 times whatever that would be is 0. So there's my first answer. And then the second answer is right here. I'm going to subtract 7. And I get 4x equals negative 7. Divide both sides by 4. And I get negative 7 over 4. So negative 7 over 4 makes this 0. 0 times whatever number this would be is 0. So there's my 2 solutions. I put them in some braces. Negative 7 over 4 and 5. And there we go. Yeah. Doesn't matter the order. If you put the 5 first, comma, the negative 7 over 4, it's fine. If interval notation, it does matter. Okay, so when we did interval notation in previous units, if you didn't put in the right order, there was a deduction. Okay, this is a set, it's just a list. It doesn't really matter the order. If you were to take, if any of you do happen to go take MGF 1106, Topics in Math, the first unit there, we talk about working with sets and operations, and it's loads of fun. And it's still not required, but it's handy to put it in number order or alphabetical order, because when you have to work with them, it makes it easier to know what to do. So that's why my habit is to write things in number order. All right, so here is my last example, and then for the rest of the class, you're just going to work problems to get used to doing this process. So here's my example. I'm going to solve this quadratic equation right here. We're going to solve x squared plus 5x minus 24 equals 0. Just give me a second to write it down. We're going to work this one together. You know everything you need to know now to solve this. It's just putting it all together in the proper order. So since this is equal to 0, this is important. If that's another number, if that's another term, we'll have to do something. We'll talk about that in a future example. But for now, it's in the format that I need it to be in. So what I'm going to do is I'm going to apply my powers of factoring that we talked about for the other 3 sections. So here we go. This has a 1 in front of the x squared, so I'm just going to unfoil it. X squared is x and x. What do my signs have to be according to the negative 24? Positive and negative, or negative and positive, doesn't matter what order. Positive and negative sounds fine. And then I need the 2 factors of 24 that are 5 apart. And what are those? 8 and 3. I'm going to put a positive 8. I'm going to put a negative 3. There we go. In case you don't know why I put the 8 with the positive, they have to add up to a positive 5. So positive 8 and negative 3, when I add them, gives me positive 5. That's why I chose that. Are we good up to this point? That's factoring. If you haven't gotten to the homework yet, please, you have 5 days until the test. Do that homework, take those quizzes. Please, I want you to do amazing on this test. This test you're going to have Tuesday is very straightforward. I'm going to give you a test to say factor, and it's going to have a few solving at the end. Okay, there's no mysteries if you've done the homework. So now at this point, I have 2 numbers I don't know equal to 0. So I can now apply the principle of 0 products and set each factor equal to 0. The first one, when I subtract 8, is negative 8. The second one is plus 3. Before I write that down as a set, just want to tell you, you can also check your answer. Okay, so like if I take the 3 here, 3 squared, what's 3 squared? 9? Sure. And then what's 5 times 3? And then minus 24, and then you pop out your calculator, and 9 plus 15 is 24, and 24 minus 24, oh, that's 0. Perfect, it worked. And the same would happen with the negative 8. If you plugged it in, it's going to add up, everything's going to add up to 0. So here are your 2 solutions, negative 8 and 3. And there we go. Done. That's it. If you can understand that problem, all these other problems you're going to do are just variations of the same thing. Hopefully we get good and comfortable doing it. Quadratic equations will come into play in the next unit as we're looking ahead and we're applying factoring in other situations. So here's your next problem. Please do this. X squared minus x minus 6 equals 0. All right, so this starts off with factoring. Again, there's a 1 in front of the x squared, so the factoring is just unfoiling. X squared is x times x. My signs are going to be one of each because it has to multiply to a -6. And then the two factors of -6 that add up to -1 are going to be -3 and +2. So whatever order you have your two factors, I've said this before, you can have the x minus 3 here, the x plus 2 here equals 0, but you do have to have the same exact two factors. So once again, two things multiplied together equal to 0. So x plus 2, I'm going to see what these individual numbers could be. First one's -2. And the second one is 3. So there's your two solutions. You can check them if you want, just for time's sake. I'm not going to. There's my two solutions, -2 and 3. All right, if you have a question, please raise it. Let me know. I'm just going to keep going so we can get some more examples in the meantime. So the next one, try this. You've got x squared minus 49 equals 0. From our last section, hopefully you recognize this, difference of squares. So x squared, my firsts are x and x, 49, my lasts are 7 and 7, plus 1 minus the other, or minus and plus, whatever you want. Difference of squares. Take the two factors. So the first one, the first solution here is going to be -7. The second one, when I add 7, is going to be +7. There's my two answers. And when I put that in form of a set, I have -7 and +7, and there it is, we're done. If you got a question, comment, or concern, here's the next one. You're going to give me a little advice on this one before you get going. We've got x squared plus 21 is equal to 10x. Because we have two different factors, we have x plus 7 and x minus 7. So there are two numbers that I can plug in for x. When I square it, I get 0. So plus 7 definitely works. 7 squared minus 49. 7 squared is 49 minus 49 is 0. But then -7 times -7 is +49 as well. So that's why there's two answers. So on this problem right here, what's the issue that we have to resolve first? It's not equal to 0. How do I make this equal to 0? I'm going to move the 10x over to here. Great idea. Last thing I want you to let me know. When I do move the 10x over here, where does it have to go? If we're going to write this in descending order, if we're going to have it in the standard form, it needs to go in the middle between the x squared and the 21. That way I know what my firsts are and what my lasts are. So I'm going to give you 90 seconds. Bring that 10x over, put it in the middle, and see what you can do. So I'm just doing what you said. You told me to bring the 10x over because it's got to be equal to 0. So that was good. You internalized that. The 10x has to go in the middle so that my trinomial here is in the standard form of degree 2, degree 1, and then no variable at all. And so now I'm ready to factor. The x squared is x and x. My signs have to be the same according to the positive 21, and they're both going to be negative. So negative and negative. And then the two factors of 21 to add up to 10, I'm hoping you said are 7 and 3 or 3 and 7. The order doesn't matter at that point. So now we're almost done with this problem. Just going through the final couple steps here. And the first solution is 7. And hopefully you're seeing it's the same steps every time. Okay, it doesn't, once you've got this down pat, it's the same thing, doesn't vary at all. And so we've got 3 and 7. Got just a few more problems that we're going to do, and then we'll see what comes next. So here's the next one. Try this. 3x squared plus 12x equals 0. So two little hints for you. First, remember the factoring strategy we just wrote on the board a few minutes ago from section 5.4, and then observe this isn't a trinomial. So that's my second hint to you when you're approaching it and how you're going to factor. Just to give you a nudge, what's the first thing we're always supposed to look for when it comes to factoring? Common factor. So if you're looking at this and you don't know where to start with the common factor. And then you're going to see that's all there is to it. And finish the problem. So common factor. Between 3 and 12, the common factor is 3. Between x squared and x, the common factor is x. This was the first factoring strategy that we learned or talked about last week. 3x squared divided by 3x leaves x. 12 divided by 3 leaves 4. I had an x, I factored it out, no more x. And so on this one, there's no unfoiling, there's no grouping method, there's nothing. It was just a factor out the common factor. This is not factorable anymore. It has two terms, but it's not a difference of squares. It's not a sum of cubes. There's nothing left to do here. These are my two factors, 3x and x plus 4. So I'll take these two factors now. Same thing. I don't know what this number is. I don't know what this number is. but I do know when I multiply them, I get 0. So that means either the 3x is 0 or the x plus 4 is 0. This case here, 0 divided by 3. If you have $0 divided by 3 friends, you're giving each of them 0. And then when you subtract 4 over here, you get -4. There's your two solutions to this one. You can plug them both back in and see that they 100% are going to work. And there's my solution set, -4 and 0. So don't always, the reason I give this problem, and I like it, is don't always just approach every problem like you've got to have 2 sets of parentheses. Okay, make sure that you're actually doing the problem that's given to you, not the problem you assume that it is. All right, here's the next problem. This is the first time I'm giving you one that has a number that's not 1 in front of the x squared. It gives us a chance to review because we do have a test on Tuesday on this stuff. So here it is, 2x squared minus 11x plus 5 equals 0. So use the grouping method if you need to, or however you like to factor things that have a number in front of the x squared. All right, I'm going to get started on this. If you're still working, keep working. If this problem's giving you fits, then I would recommend practicing, or send me some questions and we can talk about them, because even though there's a number in front of the x squared, this is not what I would call the most difficult type of problem like this. So just to refresh your memory, the grouping method goes like this. I'm going to take this times this, the first number times the last, and 2 times 5 gives me 10. Then I ask myself the same question here that I ask for the simpler style of factoring, is what 2 factors of 10 are going to add up to -11? And what did you come up with there? Okay, -10, -1, -1, -10. The order absolutely is not essential. I'm just putting them down in the order I thought I heard them, but I'm distracted by the wind coming out of the fence. Okay, so -1 and -10. So then what we do, just again, this hopefully is review. What we do with these 2 numbers is we use them as the new coefficients to take this middle term and make 2 terms out of it. So I'm going to do that. And I'm not going to worry about the equal to 0 right now because we're in the factoring part. So 2x squared minus 1x minus 10x plus 5. I took my middle term. It is now 2 terms. And for this method of factoring, the reason we do that is now we use grouping. So I will group the first 2. I will group the last 2. Out of the first 2 terms, they both have an x in common. 2x squared divided by x leaves 2x. Negative 1x divided by x leaves negative 1. For the second pair of terms, I first notice that the signs are out of order. I need a positive x term and a negative number term. This is a negative x term and a positive number term. So that tells me I first need to factor out a negative. And then the common factor to 10 and 5 is 5. Negative 10 divided by negative 5, a negative divided by a negative is positive 2x. A positive divided by a negative, 5 divided by 5 makes a negative 1. The grouping worked as it hopefully would, because I told you everything's going to factor. So if the grouping, when you're doing this on the test, if it doesn't work, you've made an arithmetic mistake, probably just a little mistake. Okay, so just go back and check your work. You should have the exact same thing, no differences at all in the parentheses. And we do. So 2x minus 1. What's left from the first term is x. From the second term is minus 5. And now I'm going to bring down that equal to 0 because we're solving an equation. You didn't quite get this one? Well, we're going to do another one. Don't worry. I got plenty up my sleeve. So now I've got two unknown numbers multiplied to give me 0. So I will set them individually equal to 0. And this first one, I'm going to add 1. That's great. I'm going to divide by 2. That sounds super. And my first answer is a half. Then over here, I'll add 5. This last bit, this is just solving equations that we've been solving since day 1. I'm hoping that's not too terrible. The second answer is 5. So my solution set has these two values, a half and 5. And there it is. I've got either 3 or 4 more problems left, depending on what time gives us to do. So here is your either third or fourth from the end problem. So we'll relax a little bit, and then we'll have another problem like that. So here's a little bit more relaxing one. X squared plus 5x equals 50. Okay, what's the first thing I have to do? What's really the challenge to this problem? The 50's got to go over there. Okay, just don't forget that. So I'm going to subtract the 50 from both sides. And once we do this, this is a pretty standard problem. The factoring is not too terrible on this one. So it's a number, the number is 1 in front of the x squared. So I can just unfoil this problem. X squared is x times x. My signs, since this is a negative 50, my signs are going to be positive and negative, or negative and positive. And then the two factors of 50 that are 5 apart are going to be plus 10 and minus 5. So there's the factoring. The rest of this, I'm going to take each of those individual factors. I'm going to set them equal to 0. And that's going to give me my two solutions. And then we'll be ready for the next problem. Subtract 10 on this one. There's answer number 1. Add 5 on this one. There's answer number 2. Here's my solution set, negative 10, comma 5 with some braces around it, and we're done. Next. All right, I promised another one. Here it is. I know you've been excited and anticipating this. So work this problem, 6x squared minus 19x minus 7 equals 0. That does factor. Okay, grab your calculator if you need to. All right, I'm gonna get started. Check your arithmetic with mine. Keep working if you're still working. So again, we got a number in front of the x squared. I can't factor it out, so it's part of the problem. So I'm going to multiply the first times the last. 6 times the -7, that gives me -42. So right away, first, what I notice is that since this is a -42, I need numbers that have different signs. So a positive and a negative, or a negative and a positive. The order does not matter at all. And I need two factors of 42 that are going to be 19 apart. 21 and 2. Yes. If you struggled with that, I get it. I understand seeing the numbers. So I told you this last time. In fact, I think we were working with 42. You've got a couple strategies here. You might know your multiplication tables and remember 7 times 6 is 42. Start with that. 7 times 6 is 42. Those are not 19 apart though, so that's not the one. But what you have done, and what your strategy should be with any number, is to break it down into something smaller that is more manageable. And so now 6 is 3 times 2. So now you can say, okay, 3. How many times does 3 go into 42? Well, it's going to be 14 times. Well, that's not the pair. And then 2 also goes into 6. How many times? 21. There it is. Okay, so that would be my strategy. If I'm working with an unfamiliar number, that would be exactly what I do. Is I find something that goes into it, use my calculator, and chip it down into something I can work with. I need it to add up to -19, so that means the 21's negative, the 2's positive. So the rest of this, I'm just going to leave the equal to 0 off while I factor. So now I've got 2 terms here in the middle, but they both add up to -19, so I'm good. And I've done this so that I can perform grouping. So from the first 2 terms, you take out the 2x, and you have 3x plus 1 left over. The next pair of terms are both negative. I need them to both be positive, so I'll take out a negative. And 21 and 7 share as 7. And when you divide here, you get 3x. You divide here, you get 1. The grouping has worked yet again. What's left from the first term is 2x. What's left from the 7 is -7. Well, what's left from the second is -7. Don't even know how to speak anymore. And now I'll bring down the equal to 0. And we're just about done with this problem. We've done the difficult part. The rest of this is taking each individual factor, setting them equal to 0 to figure out what numbers would have solved the original thing. Subtract 1. Oops, let me write that down. Subtract 1. Divide by 3. And the first answer is x is -1/3. We're just barely on the screen. And then we'll add 7 here. Divide by 2. And we get that the second answer is 7/2. So there's my 2 answers, -1/3 and 7/2. Yeah.
We have done, and for the 2x and -21, we have switched the places,
Definitely.
and then we will have on 3x and then 2x minus 7, and then again 2x minus 7.
Yep, you get the same exact 2 factors here, right? Everybody written this down that wants to write this down? Well, it's on video. So the question is, what if I had reversed that and I had the -21x and then the plus 2x, right? That's what you're asking? Great. Excellent question. So what my contention the whole time we've been factoring is this order doesn't matter. So let me show you that that's true. So out of these 2 right here, between 6x and 21x, I can take a 3x. So 6x squared divided by 3x leaves 2x. -21x divided by 3, the -21 divided by 3 is -7. There's my x. Now, we encountered this once before in an example we did. Is there anything in common here? No, but what I do notice is I've got a 2x minus 7. 2x minus 7. So what I'm going to do is I'm just going to group these together. Or if you want to, if it helps make more sense, put a plus 1 right here. You haven't factored anything out. It's 1. Or if you don't like that, just then put parentheses, 2x minus 7. I'm just putting parentheses around these 2 terms right here. The grouping worked. I've got the same two things in parentheses. And then what's left from the first term is 3x. I factored out this whole second term, but one of the very first things I told you about factoring out a common factor is you have to have the same number of terms. So when I factor out this whole thing, I still need to have a +1 there. So I have the same two terms, but they're just in the reverse order, but that's fine. Great question. I'm glad you asked it. If you're uncertain, you should definitely bring that up. Here's our last problem for the day. And you're like, oh, finally. I've been waiting for the last problem since I walked into class. Okay, here we go. Last one for the day. I've got this x plus 8 times x minus 2 equals -21. I'm going to give you a little hint on how to get started on this. I'm pretty sure all of you are looking at this and realizing, oh, we've got to bring that -21 over to the other side. It's got to be equal to 0. But here's the unfortunate thing. There's nowhere to add it to because these are factored. So what you need to do here, a little busy work for you to end the day. You need to multiply these together, then bring the 21 over. Then you can do the problem. So enjoy. Have a good time. So here we go. This is what you do. I know this is factored and the temptation is to just try to solve from here, but unfortunately this is not equal to 0. So anything you try to do here is not going to lead you to a good place. So what we're going to do here is on the left, we're going to FOIL. X times x is x squared. X times -2 is -2x. 8 times x is 8x. And then 8 times -2 is -16. In my next step, I'm going to do two things at once. I'm going to collect these like terms. I'm also going to bring the -21 over so that this is all ready for me to solve it. So I'll add the 21. I can now add it to the 16. Those are like terms. That's great news. So I have x squared, -2 plus 8 is plus 6x. -16 plus 21 is plus 5. And then over here, I just am left with 0. At this point, it's a timid problem now. This is not the worst thing we factored today. X squared is x and x. There's only one option. There's only one pair of factors of 5 at all. And hopefully they add up to 6, which they do. 1 and 5, or 5 and 1, doesn't matter what order. Take both of those things, like we have done a dozen times now, set them equal to 0, and your two answers result. The first one's -1. The second one's -5, and that gives me this solution set. -5, comma, -1, and there we go. So remember, test on Tuesday. Okay, I have office hours on Monday. I'll be in my office